Hello, welcome to another podcast dealing with factoring trinomial quadratics. In this example, we do have a lead coefficient, unlike the first example that we did just moments ago. So there's a 3 in front of the x squared. Well, the first thing that you want to do whenever you come across a lead coefficient and you're attempting to factor is to look to see if there is a common factor in all three of these terms that we could actually factor out ahead of time. Um, so what do I mean by that? Well, the number 3. 3 is a factor of 3. 3 goes into 3 one time. And 3 also goes into 6. And 3 also goes into 24. So what we can do is use the distributive property to factor out this 3. And when we're factoring out, what we're really doing is dividing. So 3 divided by 3 is 1, or 1x squared, or just plain old x squared. 6 divided by 3 is 2, so minus 2x. And then finally 24 divided by 3 is 8, so minus 8. Now we have a quadratic trinomial inside the parentheses here that does not have a lead coefficient, which makes the next step a little bit easier. So I'm going to go to a new slide here, just showing the result of that factoring. Again, 3 times the quantity x squared minus 2x minus 8. And I'm going to work on factoring this trinomial inside the parentheses. So to do that, I have got my question set up. What times what equals a times c, and what plus what else adds to give me b. So my b value here is negative 2. A is 1, c is negative 8, so a times c is negative 8. Two numbers that multiply together to give me negative 8, but add to give me negative 2 would be 2 and negative 4. Negative 4 times 2, and negative 4 plus 2 adds together to give me negative 2. So these two numbers then go into some binomials, linear factors. X minus 4 and x plus 2. And the 3, we still need it. That's one of the factors, so that's written out in front. In the next podcast, we'll also be looking at a lead coefficient situation, but one where the lead coefficient does not factor out. So check that out as a continuation of factoring.